Okay, these are the written solutions for 11.3. And so someone has a hypothesis that people walk faster when they're getting to the airport versus when they're leaving the airport. And so here's your speeds of two groups of samples. And so you can see, and the findings are summarized here. So again, just to review observational study, since no treatment was opposed, they were just viewing them as they came and left, their speeds of different people. Part B, this is, again, more in depth, this question. We're going to end up using this Welch's test in all of these situations because we don't know the variances of the population. There's things like that in the notes that you could look at, but there's the answer for that in this case here. And so we'll continue on really with the next part is answering this question. Do the individuals walk at different speeds, right? And so we got to run a hypothesis test to do this. There's your null and alternative hypothesis. Arrival is equal to departure, and that they're not equal, that one goes faster. They're different times as they arrive or depart. There's your alpha level. The sample size is 35 people. And so your degrees of freedom are 34. Again, if you're going to do some of these hand calculations from the notes, we will use StatCrunch again, technology to get that. So let's go ahead and take a look at that. We need this data here. Let's get back to this here. So in this one here, you're going to run a T2 sample t-test with summary. And so we do need those values there. So I know the sample sizes are 35 each. Let's get back to the first one, 260 and 53. 260 and 53 is the group that was departing, and then those are arriving, 269 and 34. 269 and 34. So we're just going to compare them. Remember, don't pull the variances. That's why we use the Welch's t-test. And so we're going to compare them, that they're different, and that's it. That the mean between those two is equal to 0, meaning they're the same, or the difference between the two equals 0, meaning they're the same, versus that not equal to 0 means they're different. You compute, and there's your p-value and your test statistic. You'll see that that matches up to what we get with technology right here. There's your p-value and your t-value. You can see negative 0.846 matches up with what we have over here. And so since that p-value is bigger than alpha, we do not reject the null hypothesis, and then you come up with that conclusion right there. That, again, knowing that since we're not rejecting that, we're rejecting that. So we don't have evidence to say that those speeds are different, right? That they walk at different speeds. Let's go ahead and take a look at one more question, the last one here. So we're comparing two groups, Republicans versus Democrats here. Republicans say on average, government wastes 54 cents. And Democrats say 41 cents with the standard deviation 2.6. There's 513 is the sample size. And so here, the specific construct a 95% confidence to see if there's a difference between Republicans and Democrats. So again, go to StatCrunch. Let's fix this up. I know the sample size is 513. 513. We are comparing Republicans minus Democrats. So Republicans first, we had 54 and 2.9. 2.9. Democrats here were 41 and 2.6. And so we're trying to see, is there a difference between those two groups? One, we could run again, run a 95% confidence test to see that. 95, okay, and so make that 95, compute, and so you can see the difference between Republicans and Democrats is somewhere between 12.6 cents and 13.3 cents, or approximately in there. So we would say then that based off of that, we would say that we are 95% confident, right? That there's a difference between them. And so if we were going to run a null hypothesis, hypothesis test, what we would do is we would be comparing, right? You'd be comparing, are they the same or are they different, right? And so when you run that hypothesis test, you compute, you can see you get a p-value way smaller than 0, so you would reject, smaller than 0.001. So you would reject the null hypothesis, and we would say then that there is a difference between Republicans and Democrats when you run a hypothesis test, and that matches up with what we got here on the confidence interval.